Okay, pre-calc students, we're now on page 4 of the Unit 6 review. Remember, you should be trying these problems first before watching the video, and then just watch the video for the problems where you get the answers wrong. First, we are talking about even, odd, and neither. The way you can test if a function is even, odd, or neither is you can replace the x's with negative x. So if you replace x with negative x, and you get exactly the same function, then your function is even. Even functions are symmetric to the y-axis, so one example might be the parent graph of a parabola. If you substitute negative x for x, and you get exactly the opposite of the original function, then your function is odd. And odd functions, we say, are symmetric to the origin. They kind of look like a double flip, a flip across the x-axis and across the y. One example would be y equals x cubed. And you can see that if you took this piece of the graph here on the right and you reflected it across the x and then reflected that imaginary piece across the y-axis, you would get this piece over here. We say this graph is symmetric to the origin. So in A, I'm going to replace all of my x's with negative x. I get 3 times the square of negative x plus 7 over the cube of negative x plus 2 times negative x to the fifth. When you raise a negative to an even power, it turns positive. So my numerator goes to 3x squared plus 7, so the numerator stays the same. My denominator, when you raise to an odd power, is going to keep its sign. So this is going to be negative x to the third minus 2x to the fifth. So what we have is the same on top and the opposite on the bottom. If you were to factor the negative out of the denominator, you could move it to the front. So my numerator stays the same. My denominator, I factor the negative out. And now I have the same over the same with one negative. That makes the entire fraction negative. So I would say that this function is odd, which means it's symmetric to the origin. Okay, the second one is the same procedure. You want to substitute the x's with negative x. All right, now all my exponents are odd, so all of these x's are going to keep that negative. So my numerator becomes negative 8x to the third. My denominator becomes negative 9x minus 2x to the fifth. I'm going to factor the numerator and the denominator, so take the negative out of the numerator, take the negative out of the denominator, and now my negative over negative cancels out and turns positive. So I end up with exactly the same thing I started with. 8x to the third over 9x plus 2x to the fifth. So since it's exactly the same as the original function, this function is even, and if it's even, it's symmetric to the y-axis. All right, the last one, when I substitute the negative x, I get 5 times the square of negative x minus 6 times negative x plus 32. The square of negative x is positive x squared, so I get 5x squared. Negative 6 times negative x becomes positive 6x plus 32. So now if I compare this to the original, I have the same first term, but I have the opposite of the middle term, and then I have the same last term. So this is neither even nor odd. and it's not symmetric to the y-axis nor to the origin. Okay, next we're going to talk about using composition to determine if two functions are inverses. The idea is that an inverse undoes the original function, so you put an x into a function f, and then you put the result of that into the function g, you should get the same x out because the inverse undoes the original function. So the way we can decide if two functions are inverses is we do f of g of x and g of f of x, and if both give us the result x, then we know that the two functions are inverses. So f of g, my outer function is f, something squared, plus 13 over 7. And then the something that goes on the inside is the g, square root of 7x minus 13. So when I square the square root, those two will cancel. I get 7x minus 13 plus 13 over 7. Minus 13 plus 13 cancels. 7x over 7 is x. So f of g is x. That's good news. Okay, now I'm going to do g of f. My outer function is the square root. Okay, 7 times something minus 13. My inner function is function f, x squared plus 13 over 7. So 7 divided by 7 cancels. I have square root x squared plus 13 minus 13. Plus 13 minus 13 cancels. I have square root of x squared, which is also x. So once you get x as both results, you just need to make the statement that f and g are inverses. Okay, we'll do the same thing over here. So I'm going to do f of g, and my outer function is f, so negative 5 times something minus 12. The something that goes inside is the g of x, 1/5 times the sum x plus 12. So negative 5 times 1/5 gives me negative 1. I still have the x plus 12 in parentheses and the minus 12. When I distribute the negative 1, I get negative x minus 12, which is negative x minus 24. Once you don't get x as one of the results, you know that they're not inverses. Now you could have made a mistake, so you might want to find g of f just to be sure you didn't make a mistake. But as long as you're sure that one of them does not give you the result x, you know that these two functions are not inverses. Okay, number 9, we are graphing on the calculator, and we're going to use the values we find on the calculator to find absolute minimum, absolute maximum, etc. So you need to, on your calculator, go to your y equals button. Let me see if I can slide mine over. Alright, and I put the first function on my first line, y1. So I'm going to graph it right now. And I can't quite see the minimum value down there. So I'm going to change my window. I want to see some lower y values. So I'm going to change my y min to be negative 15. And look at the graph again. Okay, so this graph has an absolute minimum right here. And I'm going to calculate that value with second trace. Minimum is 3. I'm to the left of the minimum, so I'm going to press enter. And then I move the cursor to the right of the minimum. Press enter. And then move close to the minimum. And press enter. So the coordinates of that point there are 2, negative 13. It looks like 1.99, but that's a rounding error on the part of your calculator. So it really is 2, negative 13. So I'm just going to draw myself a sketch here, and this point here to negative 13. So there's no absolute maximum because I'm going to infinity. There is an absolute minimum, and it's the y value, negative 13, at the location x equals 2. Some would say that an absolute minimum is also a relative minimum, but you do not need to relist it, and there is no relative maximum, again, because we're going to infinity. The function is increasing on the right side from when x is 2 until infinity, and it's decreasing on the left side from negative infinity until x is 2. Okay, let's look at the second function. I put the second function into my y2. So I'm going to go down to that one. Actually, let me go back and unhighlight the first one. Go down to the second one and highlight that one. So now let's look at that graph. Okay, that graph seems to be a funny little W. I want to look at it a little bit more closely, so I want to look at these values in here. Maybe from x is negative 5 to positive 5, and for the y values, I'm just going to look at 0 to 10. So I'm going to change my window. X min negative 5, X max 5, Y min 0, and Y max 10. Let's look at that graph. Okay, so now I can see more closely. I can see that there is a relative maximum here in the middle, and that there are relative minimums here and here. I'm not going to go through the steps to find every single one of those values, but we're going to see some of them right now. So to find this first one right here, this minimum, I'm going to do second, calculate, minimum, choice 3. Go to the left of it, enter, go to the right of it, enter, and go close to it. Enter. Okay, so your minimum is about negative 1.44, and that's at a location of about 2.17. You're going to find that this relative maximum right here is actually at x equals 0, and you're going to find that this relative minimum right here is a minimum of 4.6 at x equals 0.69. And then we're going to use those values to find increasing and decreasing. So your absolute maximum, you didn't have one because you're going to infinity. Your absolute minimum, your smallest value, was about 2.17 at x equals negative 1.44. Your relative maximum, that was that little bump in the center, that was 5 at x equals 0. And you had a relative minimum. It was like a bump down, but it wasn't the smallest point, and that was 4.6 at x equals 0.69. So you were increasing twice in this graph. You were increasing from when x is negative 1.44 until it was 0. And then you were increasing again from when x was 0.69. Oops, I have an extra 0 there. Until infinity. And then you were decreasing twice. Once was from negative infinity to negative 1.44, and then again from 0 to 0.69. Okay, let's turn the page and finish this up. Alright, we have some piecewise functions here. The first one is 2 lines starting at 2. You have a slope of negative 3, so down 3 and over 1. Down 3 and over 1, making several points, and you can even go back 1 and up 3 to make a few more points. Now I only want this if x is less than or equal to negative 3, so that's actually way over here. So here's negative 2. I'm going to try to estimate about where I would be for negative 3. So somewhere around here is negative 3, and I want or equal to, so I'm going to make a solid dot and try to estimate again about here. So I'm going up like this over here, and I don't want any of these dots. Okay, I'm going to do the new piece in a different color. Negative x minus 4 starts at negative 4 and has a slope of negative 1. And I'll continue back this way as well. So remember, a slope of -1 goes down 1 but right 1. I want this if x is greater than -1. So -1 is here. I need an open dot because it's not equal to, and I want the values greater than -1. So then I'm going to erase these here. Okay, in B we have 3 pieces. So I'm going to start with -x plus 2. At 2, I do a slope of -1. And I want this line if x is greater than or equal to 3. So x is 3 right here, and greater than will be this way. So erase the other points. All right, let's switch colors. Y equals 4 is straight across like this, but I only want it from 0 to 3, not including either of those points. So I'm going to erase this, and I'm going to erase this, and I need open dots at the end to not include those points. Okay, and then the last piece is -3x. It does not have a y-intercept, so that means -3x plus 0. So starting at 0, do a slope down 3 over 1, down 3 over 1. And then I want this if x is less than or equal to 0, so I want it this way. I need to include this point, and I want to keep my slope of -3 as I go back. Well, it's not quite right. Okay, it should be a straight line. It's not working out for me. I'm going to use my line tool. Okay, switch back to pen. Let's use black. So I want to include this point, and I need an arrow right there. Alright, this piecewise function doesn't have a graph. So to find which part of the function to use, you have to pay attention to the second part. To find f of -9, I need to use the first part because it says if x is between -9 and -3. So f of -9 is going to be absolute value -9 plus 5, and then plus 5. So this gives me absolute value of -4, which is 4. So 4 plus 5 is 9. So f of -9 is 9. F of -3, I need to look and see where does x equal -3. This says x is less than -3 for the first one, so that's not it. And this says x is greater than -3. So x actually never can be -3 in this function. So we would say that this value is undefined. And lastly, f of 7. 7 is greater than 2, so we use the last piece of the function, 7 plus 3, and we get 10. Okay. Consider the graph of the piecewise function pictured to answer the following questions. The graph consists of a piece of an absolute value function and a square root function. All right, domain and range. Domain is left to right. I'm following along starting at -8. Just after -8 because we don't include that value. We get to 1 and I have to jump down here, but that's okay because I'm not leaving anything out of the domain. When I jump down, I continue on to infinity. So my domain is -8 to infinity, not including -8. The equation of the function, oh, and we have to remember to do the range as well. The range starts at the bottom and it goes up to -2. Then I do have to leave these values out of the range because they are not in it. I have to jump up to 0, and then I continue to 5, and then 5 is the highest value in my range. So this was my domain. My range has 2 parts, -infinity to -2, not including -2, and 0 to 5. All right, the equation of the function. My absolute value graph, the vertex has shifted from the origin. It's shifted left 4 and up 5. So I have y equals the absolute value, x plus 4 will shift it left 4, and then plus 5 will shift it up 5. Now that's going to be if x is greater than -8 and less than or equal to 1. And then the second piece is a square root function that has been shifted right 1, down 2, and reflected vertically. So to reflect it vertically, I need a negative in front. To shift it right 1, I need x minus 1 under the square root. And then to shift it down 2, the -2 is outside of the square root. That will be if x is greater than 1. And that's the end of the review. Make sure you go back and make corrections to all of your quizzes. You make sure you understand all of your homework assignments as well. Good luck, study.